All right, let's see a few more examples. So here we have some more, we have some power rule. So number 48, we have a power raised to another power. So we can multiply those exponents together. So we get a to the, and then 5 multiplied by -3 is -15. Since we have a negative exponent, we're going to drop it. So it'll end up being 1 over a to the positive 15. That's it. All right, number 50. So here, um, so here we're multiplying this term times this term here. But remember, before we multiply, we have to deal with the exponents, right? So we're actually going to do power rule first. So we're still observing order of operations like we normally would. So I'm going to multiply, I'm going to keep the 3x to the 16th the same, but I'm going to multiply these exponents here, right? So I'm going to get, let me do it like this, multiplied by x to the -12th power, right? Okay. And so now I can combine these like bases together. So when I multiply bases, I add the exponents. This 3 in the front, there's no other constant to multiply by, so that 3 is just going to stay a 3, stay the way it was. And then with the x's, I'm going to add the exponent, so 6 plus -12, or excuse me, 16 plus -12 would equal +4. So that's it, positive exponent, number simplified, one of each base, right? We start out with 2 x's, now we only have 1 x with 1 exponent, so we're all done. 52. So here I'm going to do power rule in the numerator, power rule in the denominator. So I'm going to multiply those exponents. So -3 multiplied by -3 is +9. -1 multiplied by -4 is +4. So now when I divide bases, I can subtract the exponents. So I'm going to get a single a, right? The base, I just end up with one base, and then 9 minus 4 is 5. Okay. All right, let's try number 62, and then I think y'all have the rest. So number 62, so remember that we could use the power of a quotient and just distribute the outside exponent to all the inside exponents right away. But I would recommend simplifying inside first, because if you do so, you'll end up with fewer bases and fewer things to multiply by. So I think it'll just save you work, and you'll deal with smaller numbers for the most part. So, and there's a couple things we could do. One thing is we could flip it if we wanted to right off the bat and make that positive. So there's a few things we could do, but I'm going to just keep it the way, I'm going to ignore the -3 on the outside for now and simplify the inside. So first of all, I have 2/6. So I can reduce that to 1/3, right? So I'm just going to start collecting items here. So I have a 3 on the bottom. Then with the s's, since those are like bases and I'm dividing them, I can subtract the exponents, right? So I can end up with s, and then I'll subtract -1 minus 2, which is -3. Okay, with the t's, I can subtract those exponents, so it would be 3 minus -4, which would be +7, right? Okay, and then I have that -3 on the outside. I'm ignoring it, but it's still there. All right, so now since I have a negative exponent with the s, I'm going to drop it to make the exponent positive. So the t to the 7th stays on top, the 3 is still on the bottom, and now the s is going to be on the bottom with the 3, so s cubed. So then I have that negative exponent there. Okay, so now I'm going to use the negative exponent to flip. So I'll flip this over. So it'll become 3s cubed over t to the positive 7th to the positive 3rd power. All right, now I can distribute the 3 to all the inside exponents. Don't forget about that invisible 1 by the 3 that's there. So it'll be 3 cubed s to the 9th over t to the 21st. And then, so we have one of each base, right? We went from multiple s's, multiple t's to one of each. We went from, we have one exponent for each of those. We have positive exponents, right? The only thing we have to check off is make sure our constants are simplified. So 3 cubed, we can simplify that to 27. All right, so we get 27s to the 9th over t to the 21st, and that's our final answer.